Dear students, electricity is very crucial for our life. Think about one day you don't have electricity. How should be the night that are full of dark? Or you can get some light from candle, but it's still very weak light. And also think about a hot day in summer days in tropical countries like our countries. The temperature is so hot, and we really need the air conditioning to reduce the temperature in the room. So this air conditioner really needs the electricity to operate. And the other case is you are making a phone call to your friend and the cell phone runs out of energy. And in that case, you really need to find where is my charger? You need the charger to charge the electricity to the phone, and then the phone can operate as normal again. So you see, electricity is very crucial. And in physics, electricity involves a few concepts like that. Today, I'll teach you very important concepts about resistance, voltage, and current. And I expect you, after the lesson, you can understand the concepts of voltage, current, and resistance, and the relationships among them. And also, I expect you understand how to measure each of the three electrical quantity. Regarding the English for specific purpose objective, I would like you to remember the key terms: electrical potential, voltage, voltmeter, conductor, resistance, current, ammeter, circuit, wire, resistor, lamp or bulb, switch. Okay. Now, let's go to the lesson today. Now, I will show you first of all the concept of flow of charge. In this case, a lamp is connected with a battery via a switch. Now, the switch is off and the circuit is open. Now, the switch is on and the circuit is closed. And you can see the flow of charge that go along and go through the lamp and go back to the batteries or to the electrical source. So you can see a small green stuff here that represents for charge. And when we have electrical source here, there will be an electrical current. When the switch is off, the circuit is open, so it's no current, no electrical current. And the switch is on again, we can see a current again. What is the direction of the flow of charge? So in physics, flows of the positive charge is from high electrical potential to the low electrical potential. So from high to low electrical potential. And you hear that is quite similar to many kinds of flows in physics, as I can show you here, a flows of air, that is wind, a flow of heat, I think you know, and flow of water, that is very common phenomena, you see. Now, flow of air is from high pressure area to the low pressure area. Flow of heat is from the high temperature object to the low temperature one, or the high temperature area to the lower temperature area. And flow of water from the high point to the low point. Let's look at the waterfall as example of flow of water. You see the tendency of the water that flow from the high point to the low point. And I think it will end up to the sea. You see here the analogies between the flows of charge and flows of different kind quantities or different kind of stops in daily life. Now, the current or the flow of charge is through a conductor, so we need the conductor to carry the flow of charge. So what is a conductor? Conductor is an object that allows the flow of charge or that allows the electrical current passing through it. There's a few examples of conductors, like a motor which can spin. Think about the fan. And for example, another one is alarm, which can be lighted. And then the resistor. And in some cases, the electrical wire, we can also call that a conductor. But in a normal electric circuits, we focus more on the resistor, on the motors, on the alarm. And the conductor is often made by metal. Some metal here, like copper, aluminum, is very good conductor. But also in some cases, liquid like salt water also conduct the electric current very well. But the question is, when is there the current go through a conductor? What is the condition to have the current that goes through the conductor? The conductor alone might not have the electric current through that. Like we have a lamp, but we do not have electrical source. The lamp is not lighted. So the condition for the current through the conductor is there must be the electrical potential differences between the two ends A and B of the conductor. In other words, there must be a voltage. Voltage also the synonym of electrical potential differences. There must be the voltage across A and B, or there must be the voltage of the two ends of the conductor. But you know that electric current is invisible. How can we observe the current through a conductor? Well, there's a few ways. If we use a measurement device, we can look at the display of it. And if we see the light from a lamp, we can also say, wow, there is a current through the lamp. And if we see the motion of the motor, we can also say, because of the current through the motor is operating. And if we feel the heat on the surface of the resistor, we feel, wow, there must be a current through that. Let's look at the simple circuits. In this case, the switch case is on. There is electric current from the point A through the conductor and to the point B. And we use the symbol U to represent for the voltage across A and B. And you know, voltage is measured in voltage. And we use the symbol V to represent for voltage. Now, we use the symbol I to represent for the electric current. Electric current is measured in ampere. And we use A to stand for ampere. And that is the electric circuit we have. But how to measure the voltage? How to measure the current? In physics, we use a measurement device to measure a certain physical quantities. In this case of measure voltage, we use voltmeter. How to remember these terms is easy. Voltage, voltmeters. So in this case, we connect the two ends of the voltage with the two ends of the conductor. So we call that we connect the voltage in parallel with the conductor. And then we use the ammeter to measure the current. And it also more or less the same way for us to remember the name. The current is measured in ampere, and the names of the tool to measure the current is ammeter. We connect the ammeters in series with the conductor. It means we connect only one end of the ammeter with only one end of the conductor. Now I will demonstrate to you two things with very simple experiment. How can we recognize the current in a circuit? Before I say a few ways, I explain a few ways. But how? In reality, I will show you with experiment. And second, very important for the practical work, for the experimental skill, how to measure the voltage E and how to measure the current I. Let's go to some simple experiment. I will show you how. You know that electric current is invisible, but how we can define the existence of current that go through a conductor? Now, first of all, I will introduce to you a few components of the experiment. The most important things I would like to introduce to you is the conductors. I have three types of conductor here. First of all, a lamp. Second is a rotor. The rotor has a wing which can rotate around a phase axis. And the third conductors I have is a resistor. Now, I will connect the first conductor here is a lamp to an electrical source, or we can also say the power supply. And I connect it via the switch K. Let's look at a little bit into detail about the electric source. Now, this electric sources can provide the voltage from 0 to 12. So, for instance, I want to apply the voltage of 6 volts to the conductor. So I switch to the mode of 6 volts. And of course, I will use the 2 port, which is corresponding to the direct current. Now, you see the switch case here, it is still open. So it means there should not be any electrical current go through that. Now please look at the lamp. I will close the circuit. You will see what happened to the lamp. Now, you see the light from the lamp. So it means that in this situation, the electrical current already goes through the lamp. Let's open the circuit. So now there's no electrical current passing through the lamp. I will change the conductor. I will use a second conductor, which is a rotor. Now, I will close the circuit. Now you see the rotor is operating. You see the spinning of the fan of the rotor. And you can recognize now there is a current that goes through the rotor. And when the switch is off, there is no electrical current at all. Now I will change the conductors. I will use the resistor. So I also close the circuit, and you see it seems nothing happened. Now, how we can define if there is a current in the circuit or not? We will use the ammeters to measure the current that goes through the conductor. In order to measure the current passing through the ammeters, we have to connect the ammeter in series with the conductor or the resistor. So I will connect the one end of the ammeter to the one end of the conductor. And then I will connect the other ends of the ammeters back to the power supply. And for security reasons, I should open the circuit first. Now, please look at the display of the ammeters. I will close the circuit. Now this is the indicators on the display of the ammeters, which shows 0.16 ampere. So it means that there is a current of 0.16 ampere passing through the conductor. This is the voltmeter. So for this device, it has two modes. One mode is 3 volt. That is the maximum voltage this mode can measure. And the other mode, which is a little bit bigger, is 15 volt. So it can measure the maximum voltage of 60 volt. So I think better I should choose 15 volts. Otherwise, I get a big voltage and I use 3 volts, maybe I will break the device. So I will choose the larger scale first. Now, before I already explained to you, in order to measure the voltage, I have to connect the voltmeters in parallel with the conductor. So it means that, first of all, I connect again the conductor to the power supply. And then I will connect the one end of the voltmeter to the one end of the conductor. And I will connect the other ends of the voltmeters and conductor. Now, I will check everything before I close the circuit, of course. That is the routine you should have when you do the experiment with electrical circuit. Now I will close the circuit, and then we will see how much voltage this voltmeter displayed on the board. I close the switch. Now, please look at the displays of the voltmeters. Now, so there is 2 scales on the board. Which one you will read? The below one is 3 volt. That is in corresponding with the mode 3 volt. We will not use that scale. We will use upper scale, corresponding to 15 volt as a maximum. So for that, we can read the values of voltage. In this case, it is about 6 volt. So I hope you guys find the experiment interesting and somehow useful for you to learn how to handle the voltmeters and ammeters in physics experiment about electricity. Now look at also kind of investigation experiment. But I will not do the experiment, but I will use information about that experiment in the Physics 9 textbook, page number 5. If you have that textbook with you, turn to the page number 5. Now, the question is, the voltage used at the 2 ends of the conductors, as you know, cause the current I through it. But how is the current I related to the voltage U? How to answer these questions? The approach is we apply different voltage at the 2 ends of the conductor. And then for each voltage, we measure the current through the conductor. And of course, we will use the voltmeter to to measure the voltage between the two ends of the conductor, and we use the ammeter to measure the current. And then we have a series of data about voltage and current. That is the data we have, and I collected it from the textbook. What we can tell about the relation between the voltage and current now, we can observe and see it clearly. The more voltage at the two ends of the conductor, the more current I passing through it. Or we say, if we apply a higher voltage, we get a higher current. But that seems not enough to tell about the relationship between voltage and current. So for that reason, we will plot the data diagram by using the data from the table. And you see here, this is the data point, which is corresponding to the data sets we have here. Voltage 0.5 volt, and at that moment the current through the conductor is 0.3. So in this case, each set of data is represented by one data point. The x-axis is voltage, and the y-axis, or the vertical axis, is current. And if you look at a little bit more carefully, you see on one axis they have to write down the physical quantities, and also at the same time they have to write down the unit of that quantity. In this case, the quantity is voltage and the unit is volt. On the vertical axis, the quantities is current and the unit is A. Now, look back to the representation of the data in the data figure or the data diagram. You see a linear functions in the graph of current versus U. You can easily conclude that the current I is proportional to the voltage used. Or you can say the ratios voltage over current is constant. But what does constant mean in this case? In physics, this constant is called resistance. And we can derive from this formula to another one, from which we can explain a little bit further about the meaning of resistance. Now, think about the case as we have the same voltage. So the more resistance, the less currents go through. Less resistance, more currents. But what does that mean by more resistance? More resistance means the conductor resists and opposes the flow of charge. We can understand the resistance like the resistance R of a conductor is the opposition to the current through the conductor. And the resistance is measured in ohm, and we use this symbol to represent for the unit ohm. And based on this formula, you can define the relationship between 1 ohm and 1 volt and over 1 ampere. So 1 ohm equal to 1 volt over 1 ampere. Equation we have finally is current I equal to voltage over resistance. I can explain this equation a little bit further. Now, if we apply the voltage H, at the two ends of the conductor, there will be a current go through the conductor. And the magnitude of this current will be proportional to the voltage if we have the same resistance. Now, so we can, by a full sentences or by the full expressions, we can say the current I passing through a conductor is directly proportional to the voltage U at the two ends of the conductor. And then if we can also tell something about the relation between current I and resistance. Like the current I passing through a conductor is inversely proportional to the resistance of the conductor. This is the presentation of the Ohm law. Now, it's almost everything for today. I would like to teach you. Let's drop up a bit about what I have taught. When we apply a certain voltage to the two ends of the conductor, there will be a current that goes through the conductor, and the current should be defined by the fraction voltage over the resistance of that conductor. And if in this case is the potential difference between the two ends, or the voltage across the two ends. The voltage is measured in voltage, V, and we use the voltmeters as a device to define the voltage. I is electric current, which is measured in ampere, and we use ammeter to measure the current. Ammeter should be in series with the conductor, and voltmeters should be in parallel with the conductor. And the last one, the last component in this relationship is resistance. The resistance is measured in ohm. But how to measure resistance? There is still a device to measure resistance, but in case we have only voltmeters and ammeters, there is still a way to measure the resistance of a conductor. First of all, we will use the voltmeters to measure voltage, and then we measure the current by using ammeters, and then we use two measure value to calculate the resistance. That is a general picture about the lesson today. So hope you enjoy the lesson. See you next time.